Good morning, everyone. Today we will consolidate what we have learned the previous lesson, and because I'm not here tomorrow, then I will close up the SRS things activity that you have done on Friday. So, teacher, please pause the video, allow students to take out their PLD, and students, please open up your chapter 7 notes, right? And let's go. Now, the first one is if you look at the notes this time, pretty much a lot of things have been taken copied for you lah, so you see what I see as well. So let's take a look at the number pattern. Now, types of number pattern, this is taken from textbook page 181. So positive even number, say we start with 24, the next number is 26, next number is 28. Can you fill in the blank, the pink blank? What is the next even number? Do you get 30? Yeah. And if you look at the positive odd number, do you get, so positive odd number, I want you to notice that from 15 to 17 to 19, it's not really a plus 1 or plus 3 or plus 5. It's still a plus 2, right? Because 15 to 17 is plus 2, 17 to 19 is plus 2, and therefore 19 plus 2 will give you the next odd number. Now, let's say I have a multiple of 3, I could also plus 3, right, to get the next multiple. So 18 plus 3 to get 21, 21 plus 3 to get 24. Power of 2 is also a type of number pattern. So we could have things like 4, which is 2 square. Yeah, so you may want to indicate how you get the 4 lah. So 4 is actually 2 square. And 9 is actually 3 square. So to get the next blank, right, I just need to find out what is 4 square, which is 16, and 5 square, which is 25, right? Similarly, for cube, I could do with 3 cube, no, 2 cube to get the 8, and 3 cube to get 27, 4 cube, and 5 cube. Okay, but today we are going to look at one particular type of pattern, and later on we want to see how we can apply this into questions. Okay, so let's look at this common difference number pattern. Now, this is the one that you have done in activity 3 in SLS, where term n is equals to term 1 plus d multiplied by dn minus 1. In the SLS video, they didn't use n minus 1, but it's the same formula, and this formula here help us to solve the question pretty easily and directly. Okay, now let us understand what this means. Then we can go on to practice. Now, T1 stands for term 1, or the first term, and D stands for the common difference. So I want you to also indicate down. Now, this 2 is actually a fixed number. Okay, and the Tn and the n, this is what we call the variable. All right, so in answers, I can give you some, let's write down some example. So this is called a general term, so you may want to write down, this is called a general term. So example of general term, it could be Tn is equals to 3n plus 1, or example, so Tn, it could be like 5n minus 2, something like that. Okay, so now let's take a look what exactly this is and how we can use this to answer some of the more troublesome questions in a very easy way. Okay, now let us turn to the next page of your notes and look at this formula. Now this question is also on your chapter 7 notes, all right? Now, but what is not in is the one below. So let's try to write down. First, I want you to copy down the question, the numbers of the question. So 5, then 9, then 13, then 17, then 21. Now next, I want you to make a guess, right? How do I get 9? From 5, how do I get 9? From 13, from 9, how do I get 13? From 13, how do I get 17, and so on. So based on your experience in the SRS lesson, you know that actually I just need to time plus 4, right? So 5 plus 4 will give you the 9, 9 plus 4, 13, 13 plus 4, 17, 17 plus 4, 21. And because of this, we say that this is actually a common difference, all right? So this term here is very crucial. So I want you to write down, this is actually a common difference. Common difference means that the difference is the same. So it's always a plus 4, and a plus 4, and a plus 4, and a plus 4, right? So in this manner, we say that term 1 is actually the first term. So looking at the sequence, term number 1 is actually 5. You see that? And the D actually stands for common difference. So the common difference here is 4, plus 4 to be exact. So let us put these two numbers into a formula. So term n is actually term 1 plus D bracket n minus 1. And if I put this into the formula, I will get Tn, term n is a variable, so I don't know what is it, so I just write as term n. T1 I replace with 5 because that's the first term, plus 4 because the difference is plus 4, bracket n stays as n is a variable, and minus 1. Now we want to simplify our answer. So what I do is I see a bracket, I will expand the bracket. So expanding the bracket, I will have 4 times n, 4n. 4 times minus 1, minus 4, right? Now next, I want to simplify the numbers. So look at the 5 and minus 4, they are the numbers. So you can group these two together, and you will get 5 minus 4, which is equals to 1. So you could write term n is 1 plus 4n, or you could write term n equals to 4n plus 1. To me, both are equivalent, so I won't be bothered to really switch the position. I will probably write the answer as the first one. Okay. Now next, I want to understand how is this formula useful, right? So what we could do is we could really look at the general term and figure out. So let us go back to the question. Now say for example 5 and 9 and 13 and 17. So 5 is the first term. So 5 is the first term, and 9 is the second term. The third term would be 13, right? And the fourth term would be 17. The fifth term would be 21. So what does this formula means? This formula actually means that if n equals to 5, we can now replace all the n with 5. So T5 not terminal 5, not the airport, but this is the fifth term. Right, the fifth term will be equals to 1 plus 4 times 5, which is 21. So you see that is equals to 21, right? So actually this is how we can make use of the term, but it's quite silly, right? I already know term 5 of the fifth term is actually 21. But what if I want to find out like the 90th term? Now one way is I could like really plus 4 plus 4 plus 4 and I really do all the way to 90. But in real life, this could be quite troublesome. That's why I say this formula helps us to solve this in a very simple way. If I talk about 90th term, then it will be term 90, which means the n is equals to 90, right? So I can then say, oh, if term n, then n equals to 90, I could then now replace the n with 90, replace the n with 90, and then I get my final answer. Alright, straightforward. Now, next I want you to try out the question yourself. So for 1b, 1c, and 1d. Okay. Right, teachers, please pause the video and let them try these 3 questions. About 5 minutes later, let's come back. Okay, welcome back. So share your answer. 1b, do you get term n is 5n plus 2 or 2 plus 5n? Now let's take a look on b on how to solve very quickly. Now copying the pattern down, I noticed that from 7 I need to plus 5 to get 12. From 12 I need to plus 5 to get 17. And because this is a common difference, right? We say that term 1 is 7. D, the difference is plus 5. And because of that, I can calculate the term n, substituting in T1 is 7 and D is plus 5. And expanding the bracket, I will have 7 plus 5n minus 5. 7 and minus 5 is a number, so I could like group them together. So the answer will be 2 plus 5n. Right? Now look at 1c. I want you to try your answer for 1c. Do you get Tn equals to 6n minus 4 or minus 4 plus 6n? For 1d, some of you may have written 3n minus 2. I want you to know that this is wrong. Alright, so how do I write the correct way? I must put the Tn. So you can put Tn is 3n minus 2 or Tn is minus 2 plus 3n. There's a mistake here. There should be an n here. Okay. Now, let us go on to a question before you try out the homework in class. Now, for question 2, you already have this printed on your notes. Now, let's take a look at question 2. Now, question 2 wants you to copy and complete the table. And looking at the table, I see that we have figure 1 having 4 triangle, figure 2 having 9 triangle. But how it looks like just one, right? So actually, if we were to zoom in and label, we could really count. Let's try and count in rows. So row 1, row 2 got, row 3 got. Yeah. So you can see that actually row 1 there's 4 triangles, row 2 there is 9 triangle. Now in figure 1 there's 4 triangle, figure 2 there's 9 triangle. So for figure number 3, I will still count as well. So this is 9, right? 16 triangle. And this is 1, 4, 9, 16, then 17, 18, 19, 20, 25 triangle. So how do I actually want to find out what is the n triangle, right? So maybe before that we want to make a guess what is the fifth row, shall we? Now first I want to know the difference, right? So here is plus 5, here is plus 7, here is plus 9. Yeah, and this is not a common difference. So you cannot use the Tn equals to term 1 plus Dn minus 1. You're not able to do that, right? So how do we solve this? We have to then go back to how do I get the next pattern. So let's look at some of the patterns that we have. We look at page 1 again. Now other than plus a certain number, I could also have like a power of 2 and a power of 3. So 4, 9, 16, 25 are all the square numbers. Do you see that? So if I were to highlight, this number here is actually all the square number. The orange numbers are actually the cube numbers, right? The perfect cubes. So looking at the question here, it seems like 4, 9, 60 and 25, really they are the perfect square numbers. So this is 2 square, this is 3 square, this is 4 square, and this is 5 square. So to predict, this will be like 6 square. We can also draw the triangle to really find out, but I have to draw 36 triangle. And 7 square, right? 7 square, which is 49. So if this is 1, we will use 2 square. If it's 2, I will use 3 square. If it's 5, I'll use 6 square. If it's 6, I'll use 7 square. If it's n, then I'll use term n is equals to n. It's always 1 bigger, right? So n plus 1 square. So that is how I can find out the number of but in the question they didn't ask really about the general formula, general term, but they ask you, how do you find the small triangle in figure 20? So in figure 20, the number of triangle will be 20 plus 1 square, right? So it will be 21 square. So take out your calculator and let's do it. 4, 4, 1, right? Now, I want to know which triangle has 1, 2, 1 small triangle, which means first, if I want to do a reverse kind of thing, okay, maybe let's go through the proper way first. Now part 3, right? Now because I know term n is n plus 1 square, and 1 to 1 triangle means I have 1 to 1 triangles, and I'm interested to know what is n. So how do I solve for n? Now when I look at this, I see a square. So my question is, if I don't have the square, right, I can then both side minus the 1. But if I have the square, how do I remove the square? So this is what I can explore. Say for example, I got 3 square, then I do a square root. Could you tell me what's the answer? Press your calculator now. Do you get 3? Now if I have 4 square, I do a square root, you get a 4, right? If 5 square, I do a square root, you get a 5. So n plus 1 square, to remove the square, I will just do a square root on both sides. And this I'll get 11. And to find n, I don't want 1 on both sides, so I will minus 1 on both sides. So I will get 10. Now, will there be a figure in the sequence that have 2400 small triangle? It means, is it possible to have 2400 triangle and in the n plus 1 square, right? So if I were to do a square root, n plus 1 will actually end up with 48.989 something. So you see that it's not possible because it must be a whole number, right? I cannot have n equals to n cannot be it's a 5.1 term, right? It doesn't make sense. So since n is a whole number, right, n cannot be equals to never mind, we are clear that this is not a whole number, right? So it is not possible, it is not possible to have a figure with 2400 triangle. Okay, right, so with this I want you to do the questions, these questions in your Google Classroom. The questions have been uploaded to your Google Classroom. Take out your PLD now, open the exercise, do and submit on the 16th of May. So I hope you can do most of the questions in class. The remaining questions you will do at home. Alright.